Hello, welcome to this video. And on this video, we envision to give you guys a introduction about a new product that was recently released on the Alibaba Cloud international portal, and that is called AnalyticDB-Database. In a nutshell, this is a highly concurrent, low latency, and real-time processing data warehouse. So on this video, we envision to cover some of the highlights for ADB, some of the use cases based on our observations in China, right? How some of our Chinese customers are using ADB and what kind of challenges they might have. So you can relate that to your use cases and make a decision if ADB is an appropriate product to solve your business problems. And we're also going to talk about the architecture of ADB, some of the engineering decision and why decision was made, and also a quick demo for a couple of minutes just to show you how you can actually use it in production. So having said that, let us start from a background introduction for ADB. When ADB was born, right, that was initially born, that was kind of a couple of years ago, and that was only available on the China market because ADB, the goal of ADB was initially to satisfy the customer demand on the China market. So let's take a look at the market trend in China to understand the evolution of ADB in the past years. So 5 years ago, in China, people were all about big data, right? Hadoop, and all about the 3 V's in terms of velocity, variety, and the volume, right? So that was Hadoop was a buzzword back then a couple years ago. Until very recently, on the China market, talking to our customers, talking to our prospects, I've heard a lot, and people have started talking about the speed of data processing. And the speed of data processing, it's no longer optional. And that is why the traditional Hadoop-based big data solution no longer satisfies customer demands. Right, on one side, it's a little slow, it doesn't meet the speed requirement. And on the other side of the spectrum, the cluster maintenance becomes really, really complex. It's, in a way, over-complex. There is simply too much maintenance work necessary, and it's just not simple enough for an IT, like a CIO team, to manage a huge Hadoop cluster. Now, speaking of a processing speed, we specifically refer to a real-time processing, the online processing for your full data sets. So I'm not talking about fast processing for a subset. For a lot of our customers in China, although they can split a large data set into smaller chunks, into subsets, but a lot of times when they do analytics, they need to do, as an example, a full table join. They need to join like 2 huge tables or multiple columns. And in those cases, they just have to process the full data set, right? There's simply no easy way to break it down to subsets to speed up the process. And that is why real-time processing for full data set is no longer optional in China. And that is why something like ADB becomes more and more important on the China market. So to get a sense of the problem space, let's look at some of the real customer challenges. So for example, in the banking industry, right? So talking to a banking customer, what they do is they process $140 million worth of transactions per day, right? Think of how much data that means. And in the transportation industry, right? Think of a tier 2 city in China. I'm not even talking about the tier 1 cities, right? Beijing, Shanghai, Shenzhen, Guangzhou, those cities, they generate even more data. But just for a tier 2 city, like a good average or median number is around 20 million traffic records per day. Now, when you sum it up and think about the amount of traffic records you have in a month, in a year, it's tremendous. It's huge amount of data that needs to be processed. On a separate scenario, think of a e-commerce platform. Again, I'm not even talking about something like Taobao. Those are huge e-commerce platform in China. Let's look at like an average size e-commerce platform, which might focus on a specific vertical, a specific industry. Now, for the regular size e-commerce platform, they do about 2 terabytes of data, transaction data per day, right? So when you sum it up, think of a month worth of data, a year worth of data. That's a lot of data. Right. So essentially, across all these industries, people tend to have a lot of data, and they tend to have more and more data moving forward. The second point I like to make is the highly concurrent search queries, right? And high concurrency, it's no longer optional. Especially think of an e-commerce use case, right? As a platform, I have all the sellers, and all these sellers, they try to issue concurrent queries, and everybody is expecting response in a second or in a couple of milliseconds. The millisecond level response is people's expectation. I cannot tell them that because I need to deal with thousands of sellers. For each person, you have to wait for like an hour or a few minutes for the results to come back. It's simply not acceptable. And another thing I want to mention is operational efficiency and cost efficiency. When you compare something like ADB to a big Hadoop cluster, well, it's true that Hadoop cluster use commodity software, hardware. It's usually cheaper, but when you talk about a bigger cluster, when you have thousands of nodes in the Hadoop cluster for better performance, right? The drawback is you have a very, very high initial setup cost, right? You have to own those hardware, and you have to pay for the setup cost, and not only the setup cost, but also the maintenance cost coming down the road, and not only for the machines, for the hardware, but also for the labor, right? You have to have a huge team to maintain that cluster, and you have to cover their salary. So putting all that together, this becomes more and more painful in China, and people started looking at a better solution for this type of problem. And that is why Analytic Database was born. So in a nutshell, it is a real-time, highly scalable, PB scale analytics service, right? We say it's a service because it's a software as a service hosted on the Alibaba Cloud and powered by massive parallel processing architecture, mainly for the online data value exploration, and people are expecting millisecond level response for highly concurrent queries. So that's a quick definition for ADB in a nutshell. Now let's take a little bit of a deeper dive into ADB and take a look at a bird's eye view. Right, so without giving too much information about the architecture, about the engineering design, essentially, when I personally think of ADB, I tend to think of it as the overlapping area between the 3 circles. The first circle refers to query complexity, right? When I think of query complexity, I think of huge tables. I've got multiple huge tables. I want to join these tables across multiple columns, right? So those are very, very complex computational tasks. And not only the computing tasks, but also the ETL tasks, right? So in some cases, I have my raw data stored on the object store. I like to move those data into some sort of internal storage. And in that process, I want to do transformation. I want to do a very, very complex transformation, right? So query complexity is one aspect. Another aspect I like to look at it is query flexibility, right? So for example, I've got a huge table. Well, in this case, that huge table might contain 1,000+ columns. It's extra wide table. And not only it has 1,000+ columns, but also on many of those columns, the data itself is semi-structured, right? So if you think of ID and name and gender, those are structured fields. But also, I might have some fields that contain JSON data, that contain arrays, right? That contain like a chunk of logs or a portion of documentations. right? Those large fields, they contain a lot of textual information. So when I talk about query complexity, I'm talking about, you know, handling those kind of large table with 1,000+ columns and with a lot of semi-structured fields. And the last aspect I want to highlight is performance, right? People always want to get live updates, online response. I need to see the response in a matter of milliseconds or in a matter of seconds. It's not acceptable to wait for minutes or even hours to wait for my results. So from a backend engine perspective, we're talking about millions of transactions per second, and we're talking about tens of thousands of queries per second. Now, if you look at these three circles, performance, query complexity, and query flexibility, when you marry the three circles, the overlapping area is exactly the position of ADB, right? Think of it as one system, one storage to handle multiple scenarios, right? That's the definition of ADB. Now, moving forward, to be honest, it's not the concept of a real-time data warehouse is not a cutting-edge, terminology. It's not a buzzword. It's been there for quite a while. So it's more of a way to serve the very, very complex, but in the same time, very fundamental computational needs from the customers, right? Especially the enterprise customers. When you look at the global market for the real-time data warehouse, frankly speaking, is not a blue ocean. It's more of a red ocean. It's a pretty crowded space. There's a lot of players. But from our perspective as Alibaba, we are very, very proud to say that we have a strong positioning if you compare ADB with all the competitors globally. If you look at AWS, Oracle, Microsoft, IBM, SAP, Cloudera, and Huawei, right? So Alibaba Cloud offers equivalent product, right? The same level of performance, right? The same level of functionalities. So we are a strong challenger for the existing bigger guys, right? For those bigger, giants on the US market. So if you look at the Magic Quadrant from Gartner, we are very proud to say that we are a very, very strong challenger, right? So we are going to move towards the visionaries and the stronger challengers, and eventually we envision to enter the leader box in the next few years. Another view to look at it, global recognition, an ADB has a strong ranking on a third-party benchmarking test website, which is tpc.org. If you look at tpc.org, you can see where and when we published testing benchmark results, right? You can compare the price per the QPS, and you can look at the absolute performance, right? The latest results were published in April 2019. And we envision to update the results in the next few months because we just released a major version 3.0, right? The performance has been improved tremendously, and we're going to provide new results in the next few months. And also, ADB was a hot topic as a real-time OLAP database system at Alibaba Cloud, and it was discussed at VLDB Conference 2019 in Las Vegas. So if you look at those reference articles and reference data points, you can definitely get a sense of the global recognition of ADB, right? It's not, right? It was originally designed to serve the customers in China, but it's no longer a local product. It's opened up, right? It's been evolved to serve the global market, right? That is also the vision, right? We definitely envision to enter the bigger market for bigger opportunities and to solve bigger challenges for our customers. Now, moving forward, let's take a look at some of the major use cases of ADB so you can get a sense in terms of where ADB shines. The first use case I like to cover is the transportation use case, right? Essentially, in the transportation industry, I like to think about ADB as a shining, very, very shining product from two aspects. Number one is sometimes you need to do a real-time join in order to take some timely actions. And in other scenarios, you might want to do very, very complex analytics of your data, right? A big data. So let's dive into the two separate scenarios. For the first scenario, let's imagine that at a traffic intersection, right? There's a lot of vehicles passing the intersection, and there's a camera at the intersection to capture the image of the passing vehicle. Once the image is captured, we're going to do two things. Number one, we're going to extract the tag number from the vehicle. And number two, we're going to leverage a image recognition technology to analyze the type of the car, the color of the car, right, to make an educated guess for the make and model of the car. And we put those information together. And that generates one record for each passing vehicle, right? As you can see on this table, we've got the tag number, we've got the body color, the make, the model, the type of the car, and that's one record. Once we have those records, I can take it to join with a vehicle registration database, and that is owned by the DMV in China, right? The Department of Moving Vehicles. Now we are talking about tens of millions of registration records, and for each incoming vehicle, I'm going to extract information, join with my registration database in order to identify if the captured tag number is valid or invalid, right? There might be criminal activities going on and people like to use a fake tag number, right? The identified, the car, the vehicle information doesn't match with what we have in the database. And that's definitely going to trigger timely actions. If you think about that use case, it's very, very, very important to provide a millisecond level, or maybe within a few seconds, to provide a response, allowing the police department to take timely actions. If it's too slow, right after a few minutes or even like an hour, the car is long gone and there's no way for you to, or it becomes really, really hard for you to capture the driver, right? Something might have happened already. It's too late. So we need to get the results back in a matter of seconds. Another scenario, right? It's not so much of a real-time scenario, but working with our police department, sometimes, right, they want to track very specific criminal activities, right? So they take a big table, right? A big table in terms of the traffic data in the city, right? In the tier 2 city, just to give you a sense of the magnitude of the data, we have about 10,000 traffic cameras in that city, and those 10,000 traffic cameras can generate tens of millions of new records per day, right, to capture the image of each moving vehicle. And we like to keep half year worth of traffic records data, and we are looking at tens of billions of rows and 20 to 30 terabyte of data in total, right? 20 to 30 terabyte of data. Now, when the police department likes to track the criminal activities, they take that 20, 30 terabyte of data and join with our registration database, right? With multiple tables in the historical database for tracking purposes, right? It's although people might not look for millisecond level response in that case because the amount of data, but it's still a very, very time sensitive activity. So I need to get the results back in a matter of minutes. It's even better if I can get the results back in a matter of seconds, right? So it's a TB to PB level or TB to PB scale analytics for historical data processing, as well as taking timely actions for to make real-time decisions, right? So those are the two scenarios under the transportation industry. Now, moving forward, another industry I like to talk about is a use case in the e-commerce industry. So for example, to understand the user needs, as an individual business owner, so what I want to do is I want to query the e-commerce platform data points so that I can make business decision for myself. So for example, if you take a look at the query below, I've got two tables. as a business owner, right, I like to play with my data. I like to know, for example, a number of males paying more than $100 for female clothes, right, for their families, for their wife, and stuff like that. So I can write a query, issue that query to the e-commerce backend, the e-commerce platform, and I'm expecting results back in a matter of seconds and milliseconds. So if you look at the challenges in that use case, first of all, this is a PB scale data. When you look at individual seller, it might not be PB scale, but when you think from a platform perspective, there's like millions of sellers trying to issue queries, right? So there's a lot of queries, and each query, it's effectively asking for data in a huge table, right? In a huge platform level data table, and it's huge table, right? It's PB scale, and it's a very, very complex join operation across multiple tables with billions of rows. So that's a lot of data. That's the first challenge. The second challenge here is it's a very, very ad hoc query conditions. So for example, right, I'm a business owner. I like to query one day number of males paying more than $100 for female clothes. I want to increase that filter from $100 to maybe $150 or $500, or maybe decrease to $20. So I'm gonna adjust my filter conditions in real time in order for me to get my business insights. And because of that, it's really, really hard, or even no way for the platform to predict the user filters and the query conditions, right? Because of it's impossible to do the prediction. It's really, really hard for the platform to pre-generate those data points in the cube, right? In the in-memory cube with a reasonable size, right? It's basically saying there's an infinite number of filter conditions to query all of my data points. There's basically no way to, even if I'm willing to leverage all of my memory space, there's simply no way to pre-populate a cube to store all those data points for every single seller. And the last challenge is, of course, high concurrency. Think of, you have thousands of sellers trying to run very complex queries per second, right? So how a platform can handle those amount of requests? That's exactly where ADB shines as a real-time data warehouse. Another use case, imagine that you are a IT professional working on network monitoring. So for example, I've got a whole lot of network data. I've got packet data, I've got events, I've got logs, I've got maybe net flow data, aggregation data, and all those data. And when you talk about network data, we are looking at huge amount of data, because if you think about internet, you just keep generating data, right? There's a lot of data every second. Now, when I have all those incoming data, what I like to do is I likely want to implement a streaming application to do a pattern matching, to do a windowing functions in order to generate real-time alerts, right? So by analyzing the pattern of my logs, I can identify a abnormal behavior when the pattern is matched. So once I identified a abnormal behavior, then there's an alert going to be sent to the operational people, right? And then from the point where the operational people receives the alert, there's typically a required response time, right? Within 30 seconds, within 45 seconds, or a minute, they need to start taking actions. Now, so you have a 30-second window. What you need to do is, I want to, based on the alert message, I need to issue some interactive real-time query to get the results from a long-term storage, right? That's no longer the scope of the streaming application, right? The stream processing application. And instead, I like to issue some queries to something like ADB to get the results I want in order for me to take timely actions, right? So I receive alert, that's on one side, but on the other side, I like to issue interactive queries in order to take actions, right? So that is a perfect scenario where ADB can be used in conjunction with the streaming application hand by hand to solve the network monitoring use case. And just to give you guys some numbers, right? So Alibaba, if you think of Alibaba as a company, we own many business lines, right? The maps, right? The e-commerce, the Taobao, the Tmall. We have also the movie, the modernized movie company. We have Alibaba Cloud. We have logistics. We have financial services. There's many business lines. Now ADB has been heavily tested internally, and ADB is now used to support 300 plus business lines and business units within Alibaba. And then to share some other numbers, so for example, on the single database, right, the single largest database, we have seen people, creating 20,000 plus table within a single analytic database. And we also have seen people having 3 petabyte plus data with hundreds of millions of queries per day on a single database. And in the largest ADB cluster, our observation was 2,000 plus nodes. And we have seen hundreds of query per second in a very complex analytical scenario. So all those numbers, all those data points is just to give you a sense of how much test ADB has gone through internally before we opened it up to the public to serve our customers on the public cloud. So you should be confident about the technology. Moving forward, let's do a technical deeper dive to understand some of the engineering decisions, some of the architecture design, and why architecture looks as is today. So the first one is a high-level reference architecture. So this tells me how my data can get into ADB and how I can analyze ADB, or how I can visualize the data from VDB. On the left-hand side, if you look at data sources, right, we're looking at all sorts of data, right? The metrics, the logs, and files. When you have those type of data, usually you will want to stream those data into a MQ broker service. Think of Kafka as an example. So you can have a Kafka producer on the left-hand side to grab the logs, the files, and ship it over to the broker service. And on the other side of the house, you can then configure a Kafka consumer to take data from the broker and convert those data points, those records, into insert statements. And you can run those insert statements to add data into your ADB cluster. Now, another channel for data to get into ADB is if you look at the RDBMS, the bin log, right? So we have something called DTS. It's a data transmission service, very similar to Golden Gate in a way, specifically designed for change data capture, right? So whenever you have inserts, updates, and deletes in the upstream database, you want to replicate the inserts, updates, and deletes, the activities in the downstream database, right? Think of ADB as a downstream database, and DTS is a tooling to keep the upstream and downstream databases in sync from time to time. Another way to get data into ADB is through some sort of a data integration solution, right? And those are native integration solutions. If you look at the left-hand side, we are talking about RDS, that is Apsera database for MySQL, SQL Server, transactional databases. There is integration, internal integration between the TP databases and the AP databases. And also, we also offer integration solution between ADB and OSS. So think of OSS as the object store on the Alibaba Cloud, right? Similar to AWS S3, similar to Google Cloud Storage, similar to Azure Data Lake Store, and stuff like that. And then ODPS is the C++ version of Hadoop, right? So rewritten Hadoop, much better performance, easier management, and we also provide integration solution between ODPS and ADB. So you can quickly move your data from ODPS into ADB, right? For better performance, for real-time online processing. Now, once you have data stored and moved into ADB, you can then use all the tools on the right-hand side to visualize your data, right? To issue queries, you can use ad hoc SQL queries via something like MySQL, Workbench, or you can use a whole bunch of BI tools. And something to mention that in the latest Tableau release, we have added a native connector for ADB, right? So for Tableau users, it's very, very easy for you to open Tableau, connect to your ADB cluster, and you can issue whatever. You can just drag and drop visualizations on your Tableau canvas, and the Tableau will automatically convert your actions into queries and send those queries to ADB and to execute those queries and get the results back in a matter of seconds and milliseconds. So that is the high-level reference architecture. Moving forward, another point I like to highlight is the cloud-native architecture. Remember that very different than the other traditional or classic data warehouse solution, ADB was born in the cloud, right, on the Alibaba Cloud, to initially support the internal applications and then to support our customer demands on the China market, and then now opened up to serve the global market. Right, so because of that, it's really from day one, it's a cloud-native architecture, right? So we leverage a Docker-based containerization strategy for easy maintenance, right? With monitoring capabilities, with the built-in auto-support capabilities, auto-troubleshooting capabilities. It means very, very light maintenance for the users, right? A lot of those troubleshooting, monitoring, maintenance, it's actually on the ADB side, right? It's transparent for the end users. And if you look at the cluster, without giving too much information, just think of we have coordinators and we have workers. And both the coordinators and the workers can be running on ECS within containers. That is to leverage elasticity on the cloud, right? Because we're talking about the cloud-native architecture, so containerization, multi-tenancy resource management is not optional, right? So we consider those from day one. Essentially, you have storage and compute nodes and the coordinator nodes running on ECS, which is the Alibaba version of virtual machine. You can scale in and out. You can have a smaller cluster or a bigger cluster. You can scale up and down. You can have more ESSD. You can have more storage. You can have more CPUs and cores, and you can scale down, right? So it's a very, very flexible and very, very elastic architecture design. And on top of it, we also provide option for tiered storage on OSS for cost efficiency, right? So what I mean by that is sometimes you have a hot data, right? So some data that I just collected in the past few days, I run frequent queries against those data. But when the data gets colder and colder, I might not have a frequent need to run queries against data that was collected a month ago. Now in that scenario, I still don't want to lose all my data. So what you can do is you can transfer those data from the ADB internal storage to the object store. You can compress those data stored on OSS. Now in that scenario, you can still use ADB to query that data with a slower performance, but you have a much, much, much lower storage cost for the colder data. So our recommendation for the customers, it's always keep the hottest data on the internal storage. You can get the best ever performance from ADB. And for colder data, feel free to drop those data and move them into OSS. You can still query that data when necessary, but you can save a lot of storage cost in the meantime. So that is a cloud-native architecture. Moving forward, we also have a very, very modernized optimizer, right? So without going into too much details, just wanted to give you some highlights in the 3.0, in the very recent 3.0 release. We have a fully automated optimization strategy, right? Which means you no longer need to have a DBA to come in there to kind of manually adjust the configurations to decide what configurations work best in different scenarios. It's a very, very lengthy process and needs a lot of knowledge. And starting from the 3.0 release, we have a fully automated optimization, meaning that from a user perspective, you can now free up your DBA resources. So those people, they can now focus on more critical tasks, right? They no longer have to spend a lot of time on the plumbing work. They no longer have to spend the majority of their time on the configurations. Those are taken care of by the system automatically. Another highlight is we provide a much deeper ecosystem integration with some common tooling around the database area. So just to show you a very, it's like a very, it's a very common optimization case on production, right? So these are the numbers we observed from a real customer. So for that customer, they have very, very complex SQL. For a single SQL, the size of the SQL itself could be as much as 50 kilobyte, right? Think of 50 kilobyte. It's a huge SQL query. And for that kind of query, they have 200 plus SQL patterns, right? It's not necessarily each one is 58 kilobyte, but it's, more or less, they have some smaller ones and bigger ones, but very complex SQLs. And they do as many as 60 plus table join in one query, right? So take a second, think of the complexity. It's a very, very complex scenario. It takes a lot of work and efforts if a DBA needs to go in there to manually optimize the SQL, optimize the configuration. But now in ADB, it's all taken care of by the system automatically. You can free up a lot of human resources. That's Optimizer. Another point is high availability, right? So real quick, when the query arrives at ADB, first of all, we have a very, very intelligent load balancing strategy. So that the SLB knows where to direct the query, right? So depending on the system usage, depending on the controller and the worker load, we can automatically figure out where to send the query to. And on the controller layer, the controllers are highly available. There are multiple copies of the controllers, right? You always have backups, and it's a guaranteed zero downtime. When things happen, if one controller is down, the system is able to bring back another controller. It's actually to kind of direct the workload to other controllers while waiting for that controller is being brought back. Right, so it's zero downtime from a system perspective, right? You can have some controllers going down from time to time, but there's always backups, and there's a zero downtime for the system, for the entire system. If you look at the worker nodes, right, we're looking at the compute nodes. For each chunk of data, there's always multiple replicas based on the RAFT, based on the RAFT protocol across multiple replication groups, right? So in any case, if any worker is going down, the system is always able to bring back another worker node and to reconstruct the data points using the replicas stored on the other worker nodes. And we also offer an automated healthy status monitoring services and abnormal replica replacement. We monitor all the replicas 24/7, non-stop. Whenever a replica behaves abnormally, the system knows how to automatically replace that replica by pulling data from other replicas. So it's all automatically managed. And last but not least, we offer a transparent upgrade process. And this is very, very important for customers. If you had experience managing an on-prem cluster, the upgrade process is very, very lengthy and very painful. Maybe the scheduled downtime could be 2 hours for the upgrade process, but oftentimes things happen, it takes longer for you to upgrade. There's a lot of troubleshooting process. A lot of teams need to stay online, right? To be in a standby mode to make sure they can come in to fix problems, to troubleshoot problems. But if you use ADB, the whole upgrade process becomes transparent. It'll be handled by the experts from Alibaba Cloud. So that provides a lot of value for those on-prem customers. Reliability, right? When you talk about reliability, we have number one, it's automated backup on OSS. Although we talk about replicas across worker nodes, but it's not enough, right? So what if the whole region going down? What if all the worker nodes are going down? Worry free. Even though we have replicas across workers, and in addition to that, we also have every single data point backed up on the object store, which never goes down. So we have a replica, we have like a backup of your data on OSS. In case your whole ADB cluster is destroyed, is going down, you can easily bring up another cluster and then reconstruct your chunk of data from the never going down OSS, from the never going down object store. So you are guaranteed to have zero data loss. And you can do system recovery on demand, right? Whenever needed, bring up a new system and then just copy data from OSS. And the whole backup process, it's a async process, meaning that you don't have to wait for it. It becomes transparent for the end users. Everything happens at the back end. We also provide optimal compression strategy. When you have the backup data stored on OSS, automatically we apply compression strategy, right? So for 1 GB of data, the compressed version of OSS may be just 100 megabytes or 200 megabytes, depending on the type of your data. But you can reduce your storage cost to the minimal possible level. Disaster recovery, right? As we sort of go through the architecture, this becomes easy to understand, right? So although region A might be going down, I lose all my controllers, all my workers in region A, but because we have automatic backup on the object store, right, on OSS, I can easily back up my data into another region, right? So I can configure another ADB cluster in region B, and across region A and region B, I can replicate my data from OSS to the ADB cluster in region B. So when my ADB in region A is going down, I can quickly switch to region B in a matter of milliseconds. So it doesn't stop your business, right? Your business is never stopped. And there's also option for people, if you want the optimal performance, you can have a large standby cluster in region B from a disaster recovery perspective. If you can afford a slower performance during the transition time frame, you can have a much smaller size of ADB cluster, maybe 2 controllers and 3 workers as initial size. And when you actually need to switch from region A to region B, you then scale out and then scale up, right? So go from 3 controllers to 20 controllers, go from 3 workers to 1,000 workers when necessary, and just replicate your data from OSS to reconstruct your worker nodes. It's gonna take some time, right? It's gonna result in a slower performance, but it's more efficient from a cost saving perspective. So we offer those disaster recovery options. Now, ADB is one product, and we have 2 types of ADB, one for MySQL ecosystem and another one for PG ecosystem. So let me dive into each one of these options to give you guys a high-level introduction just to cover the differences, right? From a use case perspective, from the value proposition perspective, these options are exactly the same. It's just that one architecture was specifically designed for the MySQL users, another architecture was designed for the PG users. ADB for MySQL, right? So we have a front node. It's basically referred to the controllers. We also have a SQL optimizer to optimize the queries, to free up your DBA resources. This 西河 engine here refers to the fundamental query engine. And then we have the storage engine. So one thing I like to highlight is the way we handle storage, right? The internal storage. In ADB for MySQL, we use a hybrid storage, right? It's not 100% column-oriented. It's neither 100% row-oriented. It's a combination of both. So for example, you have a row ID from 1 to n. So when we actually store those data on the underlying internal storage, what we do is we take row ID from 1 to k, take all those rows, take the first k rows, and then break them down into columns. And then we store the first column, the ID column, the name column, the age column, the gender column in a column-oriented fashion. And then from k+1 to n, for the next k rows, we store them in a separate row group. And within that row group, it's again column-oriented. The ID column, the name column, the age, the gender columns. Right, so as you can see, this is not a 100% column-oriented, but within each row group, it is column-oriented. The benefit is when you have a query such as select a star from table where ID equals to and time equals to, because the way we organize the storage, you can quickly identify the row group, right, where your ID belongs to, and you can zoom in to that row group to scan the columns. So this can provide a balanced performance, right? Really depends on the type of query you have, but based on our observations for the MySQL users in China, this is the optimized way to handle storage for most of the users, right? To satisfy the majority of the use cases. And also we apply GPU acceleration in MySQL, in ADB for MySQL. This is still in beta, right? GPU acceleration has been implemented to solve some use cases, but not every single use case, right? If you compare the GPU-enabled ADB versus non-GPU running the TPCH queries, you can see that the GPU time, the blue bars represent the GPU performance, and the orange bars represent the CPU performance, right? And significantly for a lot of queries, especially for query 1, query 10, query 11, 12, 13, and 14, 15, you have significant difference, right? Significant improvement by leveraging the GPU technologies. So this is a ongoing effort. We're gonna gradually improve all the queries one by leveraging the GPU technology. And then for ADB, for Postgres, for the Postgres ecosystem, the bigger difference is, so yeah, just give you some highlights, right? The bigger difference is, well, it's not a hybrid storage design, and instead, for the users, you can choose either a row-oriented or a column-oriented table structures, right? It becomes a user choice. We provide the flexibility to the users. And then the PG ecosystem, right? We also provide a very, very comprehensive support for Postgres SQL extensions and tools, such as PostGIS, such as MAD-lib, etc., etc. And those are not available for the MySQL version of ADB. And also, I like to highlight, right, for some customers, they might find it easier to migrate from Redshift, right, from Redshift to the ADB for PG, because our SQL syntax, it's highly compatible, and we also provide the migration best practice guidance, right? So if you decide to migrate to ADB for MySQL, it's takes a little more efforts, and it's easier to migrate to ADB for Postgres if you choose to. All right, so that's a quick presentation to cover the highlights. In the next few minutes, let me give you guys a quick demo to see, for you to see how you can use ADB for real. Right, so this is if you log into Alibaba Cloud, I'm using the Shenzhen region in China, right? So I can have region in the US, in UK, in all the different regions that we have a globally distributed data centers in all these major cities. And in my case, I have my data stored in Shenzhen. So I'm gonna log into database first. Click this log into database. And I've got my username and password, my credentials, and click log on. And I can see that is my database here. I have a test schema as my database name. So let's do a quick demo. Now in this demo, I want to demonstrate I have some data stored on OSS, on object store. What I like to do is to write a bunch of queries to kind of move data from OSS to ADB, right? To ADB internal table. So let's see how I can do it. Now, when you log into the ADB, you have the SQL window, right? This is a default SQL execution interface. You can definitely, like I said previously, feel free to use a MySQL workbench or some like BI tooling, Tableau, MicroStrategy, whatever you want to use. In this demonstration, what I like to do is first to create a demo schema. So I got my demo schema. Let's sort of refresh. I can see my demo schema being created. And I am going to create a bunch of tables in the demo schema. And you can see those tables being created. I can either run this SQL synchronously or asynchronously in two different modes. So right now I'm kind of running the sync mode. That's why I have a sort of a window blocking my view, but I can also choose to run this in the async mode. Moving forward, I like to create an external table, right? External table pointing to a data set that is stored on my object store OSS. I'm going to create this external table. Create this external table pointing to OSS, and then in a very similar manner, just create a bunch of other external tables. And now what I like to do is to select the star from this external nation and insert into my demo schema.nation column. So insert into my local table, my internal table. Right, 25 rows are imported. Now if I run this, I can actually see those data, right? So those data were actually previously stored on OSS. Now I'm able to store those data points in the internal table of ADB and then query those tables. So this is just a starting point for you to experience how I can issue a query, how I can search my data within ADB, how I can move data from another endpoint into ADB. And of course, now I've got all these tables stored in my demo schema. I've got, in fact, 184 tables. A lot of tables are partitioned, right? Partition from 1, 10, 11, 30. There's a lot of partitions given the amount of data we have, so I can do a much more complex queries. All right, so this is a quick demo for ADB, and thanks for jumping on this